Hello everyone. Welcome to Big AI Tech for Free. Today we'll discuss about solid principles that every software developer needs to know. What are solid principles? The solid principles are actually the five key design principles in object oriented programming that help create maintainable, scalable, and flexible software. They were introduced by Robert C. Martin, who is also known as Uncle Bob. What are solid principles? S stands for single responsibility principle. O stands for open close principle. L stands for Liskov substitution principle. I stands for interface segregation principle. And D stands for dependency inversion principle. In this video, we'll talk in detail about each of these principles with real world examples as well as a coding examples as well. This is one video which you need to watch if you are preparing for interviews or if you want to understand in detail about each of these principles. Let's start diving deep into each of these. Before that, just check if you have already subscribed to the channel. If not, go ahead and smash that subscribe button. Moving on, single responsibility principle. What is single responsibility principle? This principle states that a class should have only one reason to change. That is, a class should always have a single functionality and single responsibility. So if you take a real world example, imagine a restaurant. In that, you have a chef who is responsible for cooking food, a waiter who is responsible for taking orders and serving food, and a cashier who is responsible for handling their payments. Now, if you think there is only one person in this restaurant who does all these tasks, it would be really inefficient for handling all these tasks together, and the productivity also will be impaired. Similarly, in programming, a class should have only one responsibility and should not mix multiple roles. Let's see that in detail. So what I'm going to show here is first about a bad example, right? It's not the ideal example. It's not the way to do it. So we'll take an example of employee management system. Here, what does this employee class doing? See here, an employee class has an employee details and also calculation of employee salary and storing the employee details into database. So these all tasks are being done by this employee class. Do you see something wrong with this? Yes. If you see, all the functionalities of employee related to employee is being done by one class only. And what's problem with this? If any change to salary happens, we have to change this class. If any change to the employee details, then we have to change this class, which is not the ideal thing to do. So if you see, single class is handling multiple responsibilities here. And any change in salary or employee details or database logic affects this class. And what is the main problem with this? It's very difficult to maintain and test. So how do we do this in the right way? Let's see the next example. So if you take the same example, we break this employee class into three separate classes, each one handling a single responsibility. For example, this employee class here storing the employee details, you can check this employee details class. And second, we have a separate class which actually calculates the salary, right? And we have a separate class which handles the database operations. This way we have the segregation of the responsibility of each classes. Moving on, how will this actually work? From our main program, we create a employee class and salary calculator, employee database, and we compute this based on when the employee details, when a new employee joins, details will be filled, then his salary can be computed and can be stored to a database. So what's right with this and why is this better? Each class has single responsibility. Code is modular and it's easy to maintain. If I have some changes to salary, we can go and check and change only the salary portion of that module. And if we actually change salary computation or employee data database logic, we we modify only one class. In a bigger management system, if you think in a big organization, salary, for example, a fintech team is doing maintaining, and database team is maintaining the database side of classes, and employee data is maintained by some different org. So in this way, every module is separate, so there is a clear responsibility separation, and when a change to salaries or increment hikes happen, only the fintech teams go and change that modules, and no need to change everything here. So this way, it's really a important principle to follow in software, and also it's easier test and easier to maintain this way. Recap: the single responsibility principle ensures that each class focuses on only one task. By following this principle, we create a clean, maintainable, and scalable code base. On to open closed principle. What does open closed principle state? It says that software entities, as classes, modules, functions, should be open for extension but closed for modifications. This means you should be able to extend a class behavior without modifying its existing code. New functionality should be able to add through extensions rather than changing existing code. Take a real life example. You have a restaurant which actually currently serving pizza and burgers. Later, they decide to add pasta to their menu. Instead of rewriting the menu from scratch, they can extend the menu by adding a new item, pasta, to their menu at the end. So the existing menu remains unchanged. That means it is closed for modification, and new items can be added without altering the old ones. That is, it's open for extension. So closed for modification, so that means existing menu remains exactly same, and open for extension, which means we can add the new items. So this way, in programming, we can achieve this through inheritance, abstraction, and interfaces to allow extensions without modifying the core logic. I will show you this along with an example. First, let's speak about, bad example, right? How we should not do this. OCP violation. Let's say we have a class discount calculator that applies a discount based on the customer type. So we have a customer, regular customer, premium customer, based on who the customer is. If it's a regular customer, we'll actually provide a 10% discount. If he's a premium, then we'll give 20% discount. So what do you see wrong here? It seems good to me looking at it. No, I'll tell you what is wrong here. So every time we need to add a new customer here, we need to change this class. Example, if in future a VIP customer or super VIP customer comes, then we have to modify that class, adding that, if the customer type equal to VIP, add price discount of 30%, something like that. So this really violates the OCP because we are changing the existing code. And this is higher risk of introducing bugs while adding new logic because we are changing an existing class every time a new customer type is getting added. So this example is violating the open closed principle of software architecture. Let's see a good example. So instead of modifying this existing discount calculator class, we can extend it using an interface and separate these discount strategies. Example, here you can see what I'm talking about. Separate out that functionality, this apply discount into an interface. Every customer discount type actually implements this interface and have its own class. For example, as you're seeing here, regular customer discount is implementing discount strategy and returning back 10% discount for regular customers. Similarly, for VIP customer, 30% discount. So in this way, when another customer comes, super VIP, that can be a separate class with super VIP customer discount implementing this interface with 40% discount, for example. So this way, when a new customer comes, we no need to change. Following that, discount calculator is taking discount strategy, which is this is our interface for the different types of discount, customer discounts that we're allowing, and applies the discounts based on the Past price. Main class, we create the discount calculator and pass a regular customer discount or premium discount to VIP discount, because as we created the discount calculator class, taking or injecting the discount strategy interface. So we can create whatever type of customer here wanted the discount to be applied on. For example, the bill is 1000 rupees. This also can be passed. For example, it's 1000 rupees with regular customer, 10% discount will be applied with a premium 20%, VIP 30% based on this. This is the way we need to implement the open close principle. Why is it better? Existing discount calculator class remains unchanged. You understand this, right? Easily we can add new discount types. For example, as I said, super VIP without modifying any of the old codes. Follows these open close principles for open for extension and closed for modification, as we discussed even in the real world example. Restaurant, the menu extension, keep that in mind. You will connect any similar examples, right? Encapsulates different discount logic in separate classes. This improves maintainability. We can add n number of types of customers as needed without modifying the existing customer base or customer discount strategies that we already have. Just to recap, what exactly is this? This principle ensures that existing code remains stable while allowing new functionality to be added without modifying the existing code. Moving on, L in the S.O.L.I.D principle stands for Liskov substitution principle, right? What does this LSP states? What does it state? It says that subtypes must be substitutable for their base types without altering the correctness of the program. What does this mean? This means that a child class should be able to replace its parent class without causing issues. So a subclass should extend the parent class behavior without breaking existing functionality. Clients using the parent class should not need to know if they are using a subclass. You understood this? Clients using the parent class should not need to know if they are using a subclass. I'll show you. For example, take a real life example first. Imagine we are owning a vehicle rental service. All vehicles have an engine. So you create a vehicle with a start engine method. You add a car and a truck as your subclasses. They both have engines, so everything is working fine. Now you decided to add a bicycle to the system. What happens now? Bicycles are also vehicles, but they don't have an engine. Did you realize we already added a start engine method assuming vehicles will have engines? So if we force bicycles to implement start engine method, our system will break because bicycles will not have engines. Thus, bicycle is not a valid substitution for vehicle if the program expects all vehicles to have an engine, right? So what's the solution for this? Instead of forcing all vehicles to have a start engine method, we should separate the behaviors properly. I'll show you that example. As usual, I'll show you first the violation. Let's say we have a bird class with a fly method, right? So here we have a bird, right? We assume all birds can fly and we are saying method fly for all the birds. Then what happens? We create different birds. Sparrow, which extends the bird, and then sparrow can fly, so no problem. And what happens when we create a penguin? This is also a bird which is extending the bird class, but it will throw an exception because it's an unsupported operation. Penguins cannot fly. We cannot force a penguin to fly, right? So what's wrong? It's not following the LSP. If we pass a penguin to a function expecting a bird, it will break. Call, we get this exception because we assumed all birds can fly, but here the penguins throws an error. What's the good way to do this? To fix this, we actually should separate birds based on their ability to fly. So create a proper hierarchy here. This is the base class, right? So abstract bird, right? Abstract class, we can create a bird which takes, bird name and provides method called eat. a bird can eat, right? And separate interfaces for flying and non-flying birds. We have an interface for flyable. Then sparrow extends bird and implements flyable, right? It is extending bird but and also implementing the flyable because it can fly as well. So it is implementing the fly method because a sparrow can fly. Similarly, penguin extends bird, but it no need to implement flyable because it cannot fly. It can have its own methods like swim. A penguin can swim, right? In the main method, how do we call this? We create a sparrow and we also create a penguin. A sparrow, we have a method fly. It can sparrow can eat, sparrow can fly. Penguin also can eat because it's also extending the bird. It's also a bird, but it's not implementing flyable. So it has its own properties like swim. It can swim instead of flying. So why this is better? It's following the LSP principle. Subclasses are extending behavior correctly. And now our code doesn't break if we introduce non-flying birds like ostriches as well, right? This encapsulation of the behaviors properly and helps birds that can fly implement flyable. So all the birds, if I'm adding pigeon later, I can have the flyable as well. So is following the Liskov substitution principle, which ensures the subclasses behave correctly when used in places of their base classes, right? This is clear. Moving on, interface segregation principle. So what does the interface segregation principle state? It says clients should not be forced to depend on interfaces they do not use. This means a class should not be forced to implement methods that does not need. Large bloated interface should be broken into smaller specific ones. Classes should only depend on the methods they actually use. Why is this principle important? If a class is forced to implement unnecessary methods, it leads to unnecessary dependencies, violation of the SRP, and more maintenance overhead. So, if you take a real world example, imagine a printer that can print, scan, fax, and staple. Now you want to buy a simple home printer that can only print. But if you are forced to implement all methods, including scan and fax, home printer, I don't need all those functionalities. Only having a simple print should be sufficient. But if we don't have that segregation, we will enable even the home printer to have a scan and fax, which is unnecessary. So your class would have unnecessary methods in that case, which actually doesn't make any sense. If you take the violation example as we are seeing. So here a machine with print, scan and fax, right? That's the interface. Now we are implementing for a basic printer. So basic printer is implementing a machine and it's overriding and implementing print, scan and fax. It had to implement everything. What is wrong here? We are forcing the basic printer to implement scan, fax and print as well, which actually doesn't need for scan and fax. Clients using basic printers still have access to unsupported methods and we had to throw an exception. This is violating ISP because a class should not depend on methods it doesn't. Let's go for a good example here. So applying ISP, instead of one big interface, we create smaller role specific interfaces. Example here, printer having only print, scanner interface with scan and fax machine with fax. If once we have that, we can implement based on our need. A basic printer can implement printer and override the print method and do whatever is needed for printing. Similarly, an advanced printer which implements printer plus scanner, it can actually override and implement both print and scan. Similarly, a multifunction printer, a bigger one, can implement all printer, scanner, fax machine the way it needs, right? This way, we are actually separating out the interface segregation. When we call from the main method, when we are creating a basic printer, we only call print. When we are having the advanced printer, it can scan as well. For multifunction printer, it can do everything. So this way, each class only implements what it actually needs. Basic printer no longer has useless scan and fax methods, which it doesn't need. Now, if we introduce a new device, only scanner only device, we don't modify existing code. Similarly, if we have only fax only device, it can implement only fax. So we no need to modify any existing classes. So this following ISP classes are not forced to depend on unnecessary methods here. To give a conclusion, again, to recap, the ISP ensures that interfaces are small, focused, and relevant to the implemented classes, right? Last, dependency inversion principle. The dependency inversion principle, what does it state? High level modules should not depend on low level modules. Both should depend on abstractions. Abstractions should not depend on details. Details should depend on abstractions. Let me tell that again. High level modules should not depend on low level modules. Both should depend on abstractions. Remember this word. Abstractions should not depend on details, right? Abstractions should be really an abstraction. It should not depend on details. Details should actually depend on abstractions. Let's see the example, it'll get clear. In simpler terms, if we say this, right, high level modules should not directly depend on low level modules like implementations, right? Instead, they should depend on interfaces or abstract classes. This reduces coupling and makes the system easier to modify, test, and extend. If you want, take a screenshot of this page and keep it. Example, let's take a example, right, which is a violation. Imagine we own a restaurant and you need to deliver food to customers. You directly hire John, a delivery guy with a bicycle, right? We are owning a restaurant, right, a bicycle delivery. If you see here, and he is delivering food, we have hired John, right? Here bicycle delivery is actually for food delivery. We are creating in restaurant class new bicycle delivery, which actually delivers the food. What is wrong here? If John is unavailable, right? We can't switch to another delivery method. For example, if we want to go to motorbike, a car, a drone, restaurant class is so much dependent on bicycle delivery. It's tightly coupled with bicycle delivery here. If you want to expand delivery to longer distances, bicycle delivery might not work, right? So bicycle delivery is not a feasible delivery option if you are actually targeting a larger distances. Restaurant is tightly coupled to bicycle delivery. Changing the delivery method requires modifying the restaurant class. So if we have to add one more, then I have to change the restaurant class itself, which is not ideal. Then what's the right way to do? Right? Instead of depending on John, a specific delivery guy who comes with a bicycle delivery, the restaurant should work with a delivery service provider like Uber Eats or DoorDash or anything which can offer different types of delivery. First, for that, we create an abstraction for the delivery. So the interface delivery service, it has one method, deliver food. Then bicycle delivery can implement the delivery service implementation of the interface and deliver food. A car delivery can do the same thing by implementing the delivery service. Drone delivery also can do the same thing. This way, restaurant class, it depends on the abstract interface of delivery service rather than a specific bicycle delivery. So this way, we can, based on the delivery service available, we can actually send, deliver food accordingly. How do we call this from main program? So we create delivery service, bike delivery and a new bicycle delivery. If it's a car delivery, we create a car delivery class, but the base interface is delivery service. So similar for drone delivery as well, and restaurant based on the distance, based on the other factors, it can choose what type of delivery service it want to consider here, right? So restaurant can send through bike delivery or car delivery or drone delivery. What's good here, right? The restaurant now doesn't care how the food is delivered, whether bicycle or car or drone. It only knows delivery service here, right? Then just deliver food through its send order method. If we introduce new delivery methods, we don't need to modify restaurant. So if I get another type of delivery, example, truck delivery for a large orders, we no need to change the restaurant class. We can create another class which is implementing delivery service called truck delivery. It's flexible and maintainable, we can change delivery providers without affecting the restaurant's core operations. Following DIP, the restaurant's high level module, which is a high level module restaurant, depends on an abstraction, which is a delivery service, not a concrete class, which is a bicycle delivery, which we showed in the bad example previously, right? Hope you got what uh, dependency inversion principle is. This is instead of directly depending on specific implementations, always depend on abstractions or interfaces to make your system more extensible, flexible, and maintainable. If you come this far, I'm sure you're finding our content useful. Don't forget to subscribe, smash that like button, as well as comment if you want to learn some topic. Thank you.